Kinetic energy, as I said before, is the energy of motion. And here we get to the definition of kinetic energy. Kinetic energy of an object is 1/2 times its mass times the velocity squared, where v is just here the magnitude of the velocity. Energy is, again, energy is a scalar. It doesn't have a direction. And so the velocity here is the magnitude of the velocity. You don't end up with a vector here. And in this example, there's a force operating on an object that's going to cause it to accelerate, and that acceleration ends up giving its kinetic energy 1/2 mv squared. There's a theorem that goes with this called the work energy theorem, which is really nothing other than if there are no outside, if there are no non-conservative forces and you do work on an object, then the net work is simply the difference between the kinetic energy the object had before you started, right, and the kinetic energy after. So your initial kinetic energy is here. This is your final kinetic energy. So you take your final kinetic energy, your final velocity, minus your initial kinetic energy, and you get the net work done. The way we really think about it is in this way, where initial kinetic energy plus work done by outside forces plus is your final kinetic energy. All right? Work plus net work, kinetic energy, initial, plus net work is final kinetic energy.